Okay, so we have reached the final section. Okay, we are continuing with rubber as our natural polymer. So under rubber, we have learned about the structure of a rubber molecule, which is isoprene as a monomer and rubber as a polymer, which we call as latex. And we have also looked at action of alkaline and acid on rubber. All right, so please go through the previous video. It's quite important, the section on action of acid on latex and action of alkaline on latex. Okay, now we're going to look at what is this thing called vulcanization of rubber. Okay, rubber, as we know, the characteristic of rubber, it is soft, but it is not that elastic. Okay, if you stretch it too much, it will actually permanently deform. Okay, it's not that strong, it cannot withstand heat, and also it cannot withstand oily conditions or acidic conditions. So in order to make rubber overall stronger, to improve the characteristic of rubber so that it can be used for various applications, we have this process called vulcanization of rubber. So the whole idea of vulcanization is it is a process of making rubber harder, heat resistant, and also more elastic. All right, now it's very simple. This process involves adding sulfur atoms into the rubber molecule structure. So naturally, rubber molecule structure, as you can see in this diagram, this is a rubber molecule structure. It is just planes of molecules which can slide. That means one plane, okay, and another plane. There is no connection between these planes, therefore the planes can easily slide. That's why rubber can stretch. Okay, unlike some things like metals, it cannot stretch as how rubber stretches. But in natural form, it is too weak. That means if you stretch too hard, it will break or deform permanently. So to prevent this, what we do, we add in sulfur atoms. Okay, so sulfur atoms, when it's added in, it forms a link between the two planes of the rubber molecule. Okay, sulfur drops in and forms a link between the two planes of the rubber molecules. Now in this form, when sulfur is added in, it is called vulcanized rubber. Right, vulcanized rubber. So vulcanized rubber is naturally stronger, more heat resistant, and more elastic. Okay, so you have to remember, when you want to talk about the structure of a vulcanized rubber, you talk about sulfur atoms forming cross links between the rubber molecule sheets. Okay, so it forms cross links. This is a cross link because you have a rubber molecule like this and another rubber molecule sheet like this. Sulfur forms a cross link between the two rubber molecule. This prevents it from breaking too easily and allows it to be more elastic. That means when you stretch, the links will pull back the rubber into its original shape or length. All right, so that is called vulcanization. There is two methods for vulcanization. That means to add in sulfur. How do you add in these sulfur atoms into the rubber structure or rubber molecule? Two methods. Now the first method is by heating natural rubber with sulfur, okay, with sulfur at about 140 degrees Celsius. All right, so it just involves heating, that's all. And a catalyst, as always, reactions with catalyst makes it faster. So the catalyst used is zinc oxide. Okay, zinc oxide is the catalyst. Okay, this is what you are doping in. Okay, this is what you are adding in. Okay, you are adding or doping in sulfur into the rubber structure, and you need to remember the temperature. All right, so heating is the first method, heating with sulfur. Now the second method is mixing a solution of sulfur monochloride. Okay, this is the solution, sulfur monochloride in methyl benzene. Okay, quite long the name, sulfur monochloride in methyl benzene with natural rubber. Okay, so when you mix, it is going to look something like this. Okay, you have a beaker, we have a beaker, and we have sulfur monochloride in methyl benzene, the solution. the solution is inside the beaker, all right, sulfur monochloride in methyl benzene. It's in liquid form, and what we do, all we have to do is take a piece of natural rubber. Okay, take a piece of natural rubber. I said this is natural rubber that has coagulated. Okay, just dip it in, submerge it into the solution. Okay, so you dip in the natural rubber into the solution, dry rubber. Okay, so what happens, because of the solution, the chemical formula of the solution, it will actually cause the sulfur from the solution. Okay, sulfur monochloride, there's a sulfur there as well. The sulfur from the solution will be absorbed by the rubber. Okay, there is sulfur in the solution, it will be absorbed by the rubber. So that's our idea, because we want the sulfur to be absorbed in the rubber to form the cross link. Okay, it should become like this. So both method works. Both methods is vulcanization. One is heating of natural rubber with sulfur. Another one does not involve heating. It just involves mixing the solution of sulfur monochloride in methyl benzene with the rubber. That's all. All right. So these are two methods. Next, properties of vulcanized rubber. Okay, this is our last section. So properties of vulcanized rubber. Naturally, rubber better when it's vulcanized, so it's gonna be harder. Okay, in natural form it was soft, we said. Here it's a bit harder. Okay, sometimes we need rubber to be a bit harder. For example, rubber used for the soles of shoes or vehicle tires, it cannot be too soft. Okay, it has to be a little bit harder, and it will be stronger, definitely stronger, more elastic. Okay, so elastic means it can stretch and come back to its original form, not deformed. Okay, it will not be deformed, and more heat resistant. Okay, it will be heat resistant, and finally it will be insoluble in organic solvents such as oil. So earlier when we say natural rubber, it is unable to withstand conditions which are oily, but this one can. Vulcanized rubber can, so it can withstand oil, so we say that it is insoluble in organic solvents such as oil. All right, so these are some properties of vulcanized rubber. So you may find a few more, you can add it into these notes. Okay, I hope you printed out and write out. So this is the end of chapter 4. All right, this is the end of chapter 4. Total there are 4 worksheets. Okay, and I've actually uploaded all the worksheets and also these videos, including this latest one. I'll upload it on our Google Classroom. I noticed some of you joined, maybe 4 or 5 have joined Google Classroom, so the rest please join in as well. Okay, or if you can't, then you can still access it on WhatsApp. Okay.